The physics of Iron Man. Powered armor and repulsor beams. Ever wondered what it would take to build a real-life Iron Man suit? From the sleek powered armor to the iconic repulsor beams, Tony Stark's tech is the stuff of legend. But how much of it is science fiction, and how much could actually work in the real world? Welcome back to Physics of Superheroes, Episode 2, where we explore the science behind your favorite superheroes. Last time, we swung into action with Spider-Man. Today, we're suiting up to tackle the physics of Iron Man. Let's start with the heart of Iron Man's tech, the powered armor. This suit gives Tony Stark super strength, flight, and even an AI assistant like Jarvis. But what would it take to build something like this in real life? First, let's talk materials. The suit is made of ultra-strong alloys, and in later versions, it even uses nanotechnology. In the Marvel Universe, vibranium is the go-to material for its strength and energy-absorbing properties. But in the real world, we're not quite there yet. Materials like graphene and carbon nanotubes are incredibly strong and lightweight. But they still far from being able to stop bullets or withstand the kind of damage Iron Man's suit takes. And Dan T, even get me started on the cost. Building a suit like this would probably cost billions.
The power source.
The arc reactor is a miniaturized energy source that powers the suit. In the real world, we're still struggling to make nuclear fusion practical, let alone small enough to fit in your chest. But scientists are working on it. Now, let's talk about the suit's strength. The armor enhances Tony's physical abilities, allowing him to lift cars and punch through walls. But here's the catch. Even with the suit, the forces involved would be insane. Lifting a car? That's a lot of torque on your joints. And don't forget Newton's third law says every action has an equal and opposite reaction. So, if you punch a wall, the wall punches back. Now, let's talk about one of the coolest parts of the suit, the repulsor beams. These glowing beams let Iron Man fly, hover, and even blast bad guys. But how do they work? Repulsor beams are based on Newton's third law. For every action, there's an equal and opposite reaction. When the suit shoots energy downward, it creates an upward force that propels Iron Man into the air. It's the same principle rockets use to launch into space. Think of it like this. When you blow up a balloon and let it go, the air rushing out pushes the balloon forward. Repulsor beams work the same way, but with a lot more energy and precision. But here's the problem. The energy required to lift a person and a heavy suit of armor would be enormous. And where does all that energy come from? The arc reactor, of course. But in the real world, we don't have anything that powerful yet. So, could we build an Iron Man suit in real life? Well, there are a few challenges. First, the energy requirements are way beyond what we can currently achieve. Second, the materials needed to make the suit lightweight and durable don't exist yet. And third, the heat generated by all that energy would be a huge problem. Even with advanced cooling systems, the suit would probably overheat in minutes. Imagine trying to fight bad guys while your suit is literally melting. Not exactly heroic, is it? But don't worry, science is making progress. Right now, engineers are developing exoskeletons for military and medical use. These suits can help soldiers carry heavy loads or assist people with mobility issues. And let's not forget about jetpacks. Companies are already testing personal flight devices, though there's still a long way from Iron Man's level of sophistication. Even the AI in Iron Man's suit isn't completely out of reach. While we don't have Jarvis yet, AI assistants like Siri and Alexa are getting smarter every day. Who knows? Maybe one day we'll all have our own Jarvis. So what have we learned today? Iron Man's suit is an incredible blend of materials, science, energy technology, and physics. While we're not quite ready to build a real-life Iron Man, the science behind it is closer than you might think. From the powered armor to the repulsor beams, Tony Stark's tech pushes the boundaries of what's possible. And who knows? Maybe one day, with enough innovation, we'll all be suiting up and saving the world. Next time, we'll dive into the science behind another iconic superhero. Until then, keep exploring the science of the impossible. Thanks for tuning to Elevated Excellence, and this is Physics of Superheroes. Stay curious.